Number 9. So this one we take a look, and it asks us about some of these alternating series, minus 1 to the n. So let's go ahead and work on those. So first, minus 1 to the n over n. So one good thing to note, if I give you an alternating series and I only say if it converges or diverges, one thing you might look at is, okay, does it converge absolutely? Because if it converges absolutely, then you're done for free. But we look at the absolute value, that would be 1 over n, right? And that would be a divergent series. We know that by the p-series test. So now we have to check and use the alternating series test to see if this works. So the alternating series asks first, does the limit as n goes to infinity of the a-n's go to 0? And again, the a-n's don't include the minus 1 to the n. So does this limit equal 0? That's good. And the sequence is decreasing. And I really do mean sequence here. As 1 over n plus 1, that's less than 1 over n, right? If I divide by something bigger, I get something smaller. And that's the hypothesis for the alternating series test. Do the limit of the terms go to 0, and is the sequence decreasing? So by the alternating series test, AST, sum from n equals 1 to infinity, this might be another place where I wrote a 0, of minus 1 to the n over n converges. Okay, so that's an example of one that converges. Part B, minus 1 to the n over n squared, or times n squared, sum n equals 0 to infinity is fine here, over n squared plus 1. And I want to look and see, okay, does this converge? So again, I check alternating series. First, I'm going to check if the limit goes to 0, because if it doesn't, then I'm just done immediately. So the limit as n goes to infinity of n squared over n squared plus 1, that's equal to 1. 1 is not equal to 0, so the series diverges. Okay, the series diverges, that's important, because that's the answer. But also, this doesn't have anything to do with the alternating series test. This is true for any series ever. If the terms don't even go to 0, then the series automatically diverges. Doesn't matter what kind. And then finally C, we look at minus 1 to the n e to the n over n plus 1. Look at that series, n equals 0 to infinity. So again, let's check the limit. E to the n over n plus 1. We have a fact from class, our useful limits thing. This is equal to infinity as well. But this again is not 0. Let me be careful. The limit technically doesn't exist if it goes to infinity, so I don't want to quote unquote say infinity equals 0. So I'll write it like this. The limit isn't 0, so the series diverges once again. And this is basically how it goes for checking any alternating series. Is it decreasing? Do the limits of the terms go to 0? If both of those things are true, your series converges.